we have looked at an example where it'll factor. We've actually looked at 2 examples of factoring, and we've looked at one example where there's a single trig function that's really easy to solve for. Now let's look at an example of a quadratic that won't factor. Here we'd like to find all solutions of the cotangent of x times the cotangent of x plus 3 equals 1. The first thing we need to do is remember that you cannot take it apart right now. You can't just say cotangent of x equals 1 and cotangent of x plus 3 equals 1. We're only allowed to do that if it equals 0. So we're going to have to expand it out and get it equal to 0. So our first thing is distribute the cotangent of x so that we have cotangent of x times cotangent of x, which is cotangent squared of x, plus 3 cotangents of x equals positive 1. Then we'll get it equal to 0 and see if we can factor it. Now that it's equal to 0, we can start to see that we have a problem. We could take that apart into cotangent in one parenthesis, cotangent in another. The problem is nothing multiplies to negative 1 and subtracts to positive 3. So we realize this is unfactorable. So here's where things go a little crazy. Are we ready?
No.
Okay, it won't factor, but it is a quadratic. So we're going to use the quadratic formula. Okay, let's try. Here's what you do. Instead of x equals opposite b, you simply take cotangent of x equals opposite b. And in this case, make sure you understand a is positive 1, b is positive 3, and c is negative 1. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So b squared is 9 minus 4 times a times c. All over 2 times a, which is just 2 times 1, which is 2. So we're up to here. Cotangent of x is equal to negative 3 plus or minus the square root of 13 all over 2. It's just not pretty. Okay, so everybody understands you have to clean it up down to a single radical. At this point, though, you do not have to turn it into a decimal yet. Here's what I recommend. I don't work well with cotangents. Do you?
No.
Okay. I can't handle cotangent. But I know that if did you know you can flip both sides of an equation?
Mm-hmm.
It's true. You can. So let's turn it to tangent. So let's say we know that tangent of x must equal 2 over negative 3 plus or minus the square root of 13. Okay, so we're gonna flip both sides. No, we're not gonna worry about it. We're gonna go to a decimal at this point. We are not gonna attempt to rationalize that. Okay, so that would not be fun. All right, do you guys understand that technically that's 2 totally separate things here?
Yes.
Okay, so we know that that's either tangent of x equals 2 over negative 3 plus the square root of 13, or tangent of x equals 2 over negative 3 minus the square root of 13. And this is the point where we're going to go to decimals. That is definitely not on our unit circle, so we're just going to find the reference angle for both of these. And the way that you find the reference angle, okay, so now that we know what tangent of x equals, we need to find the reference angle, okay? And the reference angle is best done from the positive, so we need to go to decimals now. So you guys tell me what this decimal is. 2 divided by negative 3 plus the square root of 13. Remember to do alpha y equals if you have that capability, and it helps out a lot.
3.3027.
I got
3.9. 3.30275638. Did you guys get that?
In radians or degrees?
It doesn't matter yet because we haven't used the trig button yet.
Now I got something to blame on.
Okay, well, this is what you should get. So everybody make sure that if you take 2 and you divide it by negative 3 plus the square root of 13, make sure that you get 3.302775638.
Can you come see what I'm...
Not right this moment, okay? Just hang on a second. All right, now go find the other one. have tangent of x equals
Negative 0.302775.
2 over negative 3 minus the square root of 13. And you got negative 0.3202775637. I'll bring it back. Okay, so we're going to pause right there and make sure everybody can get to there. Those are the two things that tangent of x has to equal. All right, I'm going to have two different reference angles for these two different pieces. So on the left, my reference angle is whatever I get when I inverse tangent 3.302775638, and we do want that in radians. So second tangent, and give me your reference angle. One more. Go one more. Uh-oh, it didn't line. Did you guys get 1.276795025?
Yes.
Okay. And then I want that to be positive 3, so I need to keep it for quadrant 1 and then move it into quadrant 3. Okay, so over here on the left side, we have a reference angle of 1.276795025, and that, because we want this tangent to be positive, we need to move it into quadrant 1 and quadrant 3. And so we already know that quadrant 1, x is going to be 1.27, I don't know, 70, something like that. And then we want to move that into quadrant 3 by taking pi minus the reference angle. So to get quadrant 3, remember you always do pi minus the reference angle if you're in radians. So give me the other one. Pi minus that reference angle. Give it to about 4 decimal places. Not pi minus, I'm just kidding. It should be pi plus the reference angle. Thank you. That would have put it in quadrant 2. What is pi plus the reference angle? 4.418387. 4.4184?
Yes.
Okay, 84. Okay, so there are the two answers we get on this side. So you can see how involved these problems get. All right, now we're going to come over here and we need a new reference angle. And I want a reference angle for tangent of x equals negative 0.302775637. But remember, to get the reference angle, it's best to inverse tangent the positive only. Never inverse tangent a negative. So inverse tangent the positive of that and give me the reference angle that you get.
Positive.
Instead of negative 0.302775637, just do second tangent of 0.30277.
0.294771301.
Did everyone get that? Okay, read it one more time. 0.294.
294013017.
All right, I'm done. Okay, that's my reference angle. But I need to move that not into quadrant 1 and 3. I want it to be negative. So I'm going to move that into quadrant 2 and 4. And remember that the way to move something to quadrant 2 really is pi minus the reference angle. And to move it into quadrant 4 is 2 pi minus the reference angle. So you guys can move that and you can give me the other two values for x. We'll pause right there. What does x equal?
X equals 5.9891840.
Okay, I want the quadrant 2 first.
Quadrant 2.
Guys, somebody read me the quadrant 2.
2.847591.
84756. Okay. And then give me the quadrant 4. 5.9892.
5.9891.
Okay. All right. Did you guys see those? Those are the 4 answers for one revolution between 0 and 2 pi. It's everything that happens in quadrant 1, 2, 3, 4 where either one of those things is true. But I want all solutions. Technically, I should take each of those and add what to it? Not 360 because 2 pi, yeah. So technically, I should say 1.2770 plus 2 pi n, 4.4184 plus 2 pi n, and then 2.8476 plus 2 pi n, And then 5.9892 plus 2 pi n. And then, if you would glance in your book, they actually only list 2 of those. Look and see which and whether you can figure out why they didn't list the other 2. Your book only lists 2 of these. Let's look and see which. Okay, so when your book listed this, they only listed, is it this one and this one? But notice they didn't add 2 pi n, they added what to it? Pi n. So what they said was, it was redundant to list all 4 because we could just list the quadrant 1 and 2 and then cut down our revolutions by half, because we can take a quadrant 1 and move it to quadrant 3 by just adding pi, right? We can take a 2 and move it to 4 by adding pi. I find that that's a little too confusing for students to try to worry about. So if you ever find that the book has ditched some things like that, it is okay for you to list all 4. It's okay, but just understand sometimes there are simpler ways to write this, and if you look at the answer in the back of the book, that's probably what has happened. They've realized that we could get the same answers by doing something a little bit shorter. So I think that is a good place to stop for now.
So, well,